Good morning, dear student. Today topic is flow of fluid. Here we study about flow of fluids, their mechanism and application. Fluid flow, that is your flow of substance that do not permanently resist distortion. That means the flow of substances that do not permanently resist. That means change in shape. And fluid is we any substance when we applied any force, shear, stress, so they displaced from one place to another place, and their shape will be changes. That is called your fluid. And an example is your gas, liquid, etc. And we have a two type of mechanism that included in fluid. One is your fluid static and second one is your fluid dynamic. Fluid static that deal with fluid at rest in equilibrium, and fluid dynamic deal with fluid under condition where a portion is in motion. And application is your working of manometers, quantification of fluid flow in Bernoulli's theorem. Then what is manometer and its types? These are the device used for measurement of pressure difference, that is called your manometer, and principle of fluid static is employed in the working of manometer. Mainly fluid static is the principle that used in the working of manometer. Type of manometer, we have mainly three type of manometer, that is your simple manometer, differential manometer and inclined manometer. Simple manometer, that is most commonly used for the difference, that is used for the measurement of the pressure difference, and differential manometer that is suitable for the measurement of small pressure differences, and inclined manometer that is less used but also used for the measurement of small pressure differences. And one by one we study about different type of manometer. One is your simple manometer. Manometer are used to measure the pressure of any fluid. It consists of a glass U-shaped tube filled with a liquid A of density, that is rho A. The arm of the U tube above liquid A are filled with fluid B, which is immiscible with liquid A and has a density of rho B. Mainly we take a U-shaped glass tube, then take a two fluid, that is fluid A and fluid B, that are immiscible in nature, and check the different point pressure differences. And let pressure at point 1 is P1 and pressure at point 5 is P2. At equilibrium, we can see that pressure at point V is equal to the pressure at point 3, and P1 for P1 plus M plus R, that is rho Bg, is equal to P2 plus M rho Bg plus R rho Ag. That means the pressure difference is equal to R rho A minus rho Bg. It should be noted that the relationship is independent of the distance M if P1 and P2 are measured from the same horizontal plane. And differential manometers, these manometers are suitable for measurement of small pressure differences. It also known as a two-fluid U-tube manometer. It consists two immiscible liquid A and C having nearly same density, that is same as a simple manometer, but difference is differential manometer can be used to measure the small pressure difference. The U-tube contain a large chamber on both limbs. And next one is your inclined manometer for measuring small difference in pressure. This type of manometer is used. Here the actual reading R is magnified manifolds by R1, where R is equal to R1 sin alpha, where alpha is the angle of inclination of the inclined leg with the horizontal plane. And in this case, pressure difference is equal to R rho A minus rho B G. By making alpha small, of the value of R is multiplied into the much larger distance R1. Then next is your type of flow. According to Reynolds experiment, this experiment was performed by the Esbon Reynolds in 1883. In this experiment, a glass tube was connected to a reservoir of water in such a way that the velocity of water flowing through the tube could be varied. At the inlet end of the tube, a nozzle was fitted through which a fine stream of colored water can be introduced. And we, according to this experiment, we have a two conclusion. One conclusion is when the velocity of the water was low, the thread of color maintained itself through the tube, fluid flow in a straight line. And second one is your, as the velocity was increased, it was found that a definite velocity of thread disappeared and the entire mass of liquid was uniformly colored. And next one is your type of flow. According to Reynolds experiment, we have a different type of flow. When the fluid flow in a parallel straight line, fluid motion is known as a streamlined flow or viscous flow or laminar flow. When the fluid motion is erratic, it is called a turbulent flow. And you can say about a wave motion, that is your turbulent flow. The velocity at which the flow changes from streamline or viscous flow to turbulent flow, it is known as a critical velocity. And Reynolds number, it is the ratio of inertial force which increase Reynolds number and viscous force which resists the Reynolds number. That is, equation is your Re is equal to rho u rho eta. That is the dimensionless group. Here rho is the density of fluid, v is your velocity, that is your speed, d is your diameter of pipe, and eta is your viscosity of fluid. And from Reynolds experiment, it was found that critical velocity depend on the internal diameter of tube, the average velocity of the fluid, and the density of fluid, and the viscosity of your fluid. Then if Re value is a less than 2000, the flow is said to be a laminar. If Re value is greater than 4000, the flow is said to be a turbulent. Then next is your energy losses. Some energy lost during the flow. According to the law of conservation of energy, energy balance have to be properly calculated. Fluid experiences energy losses in several ways while following through the pipe. They are fractional losses, losses in the fitting, enlargement losses, and contraction losses. Energy losses, one is your fractional losses. That means during flow of fluid in pipe, some friction apply on the fluid by the wall of pipe and it opposes the flow, and during this some energy can be losses. And second one is your enlargement losses, in which when the increase the pipe size, then there are the changes of some velocity. Due to this energy loss occur. And contraction losses, when we decreases the size of the pipe, velocity increase and energy can be losses. And next one is your fitting loss. When we bend the pipe, then flow of fluid direction changes, and for the changes of direction there are some loss of energies, and that is the different type of your energy losses. Thank you.